Hello and welcome to CS230. This is lecture 12 and lesson 5. And this really is just a review of everything that we've been covering in the last two lectures. We're going to quickly look at model view controller, model view presenter, and model view model once again. I'm going to use a couple of articles here just to give you a sense of how we pull all these things together. And there's a really nice blog post on combining model view controller, model view presenter, and model view model. It's worthwhile having a look because it does a fairly succinctly review each of the three using a single kind of diagram, because we pull all the various lectures and notes together from lots of different resources, but this is a nice one. So I'll also be looking at a review of an excellent article that compares the three methods that were used to build Android apps. Now we're really concerned with native mobile app development in this module, but there are a few nice lessons that we can learn from the author's efforts. Okay, and it's called MVC versus MVP versus MVVM for Android development. And again, I've given the link for this as well in this article. Okay, so basically, the author built a book searching app using each of the three architectural patterns and evaluated the apps in terms of the performance, testability, maintenance, etc. So it gives us a sense of how we might use these to design and build apps. In practice, you're going to end up using libraries like Angular, which hide all of the underlying architectural issues for you, for the two-way binding and so forth. You don't have to write your controllers, you just use the controllers. And so forth. But at some point, you might need to be concerned with some of those aspects for web interaction design. So if you think about combining the three, I keep thinking of two because I always look at model view model as just a way of looking at a version of model view presenter. But anyway, so this is a really nice one. So we see how all of the various models link up together, and how and so there's various loops of information and how it moves around between the controller, the presenter, the view, the model, and the view model. Okay. The model here, sometimes we hear in terms of a service. DDD refers to domain-driven design. You don't have to worry too much about it. It's data. It doesn't change anything from where we looked at it previously. Okay, so what he does is he separates these things out. So we look at the MVC pattern. That dictates that a feature should be divided into three components, as we know: the presentation logic, the view, the controller, which is the control flow, and the business logic, which is the model. Okay, and we see exactly how this works here. But the problem with model view controller is it doesn't specify how the view and the model could be structured internally. So if you take it literally, one could structure the view as a single class. We end up with a bloated view, which is all sorts of problems, and that means that the view is tightly coupled to the model. And because the view is tightly coupled to the model, feature requirements to the view can easily drip down into the model and pollute the business logic layer. The view is difficult to test then as well. It's very difficult to test these because the view is monolithic. It couples tightly with the user interface framework. We saw that ourselves, unit testing the view becomes really, really difficult. And just think about how you will paint. Imagine we want to paint a screen and verify that the screen's been painted in a unit test. And if you haven't studied testing, don't worry, but you'll get to it at some point in your courses. Then we have model view presenter. It's not a pattern that specifies how to structure the whole system. It only dictates how to structure the view. So model view presenter completely separates the view from the model and also solves the unit testing problem, because just does, okay? And again, don't worry if you haven't done testing, but it's quite nice. The model is the same in the model view presenter, is the same as the model in model view controller. The model should be generalized business logic layer instead of a single class. The presenter reads the data from the model, drives the view through an interface, and it makes testing the presenter easy. Okay, so all of the presentation logic should be captured in the presenter, nothing left in the view that's worth testing. Okay, problems with this then is that the controller is often omitted, and because of the lack of controller, control flow has to be also handled by the presenter. And that makes the presenter responsible for two things: updating the model and presenting the model. And then, data binding is not utilized here. So, and if binding is possible in the framework, it should be utilized to simplify the presenter. So that means that we really want this data binding, then we have to look at model view model. So with the model view model, it replaces the presenter in driving the view. And the difference is that the view model drives the view with data binding, while the presenter drives the view with an interface. Okay, so the view binds properties to the view model and updates itself when the view model properties change, and we saw that already. Okay, so instead of driving the view through an interface, the view model drives the view through changing its own properties and allows data binding to handle all the rest. Okay, so it's nice. So we have the three diagrams here, and you can see how they can connect together in this larger one here. It's worthwhile looking at. Okay, so now let's look at this really nice article that provided a comparison of the three methods to build this book searching application. So here's an image representing the actual implementation of book searching app in Model View Controller, Model View Presenter, and Model View View Model. So here's the controller, and as you've seen, the search book activity is where we start, and that's embedded in the controller because we knew that that's the case. We know that the controller doesn't, later on Model View Presenter and Model View View Model, we don't go to a controller. We actually end up going to the views in some way. Okay, so here we have some search book activity, looks at some search for a book fragment, talks to the book use case, which is the model down here. It's actually using a library service, updates the UI, and comes back again. Okay, and that's the model, view, controller. Okay, so we have the presenter here, which is the presenter talking here, this loop here, and then we have the view, which is up here, and you see the view is very similar in both cases there. Okay, and the UI is the user interface, of course. And then we have the model, and the model is pretty much the same for each of these. And in fact, if you look at model view model, the model is the same, so nothing has changed here. Okay, here we have a view model. Okay, and that actually looks at the search activity. This is the function that actually does the searching, and this then is the view model, and then the user interface. So the view interface is separate from the view model, and that's the view, and that actually gets updated. See that little arrow there? That's our data binding there, okay, which is quite nice. So it's nice. So it's worthwhile actually spending some time working through the different architectures to see the subtle differences and look at the article. So for me, anyway, some of the key takeaways that I've found, and these relate to Android development, of course, but they apply elsewhere as well. If you want to split your app screen into two or more activities, you should actually use Model View Presenter. In Model View View Model, you combine the view model through the layout to help with the data binding, and that makes a good event-driven architecture, as a result of which you can execute the specific moments of fragment or activity interaction through the interface by describing the logic in the view model. You use the Model View Model with data binding if you're working on an application with complex views, and if you're on test-driven development, use MVP or MVVM, as both work well when your project relies on test-driven development. They both have well-defined separation of concerns. So it's nice, okay? And what's interesting is the difference in the architectural patterns makes when it comes to Android development. There's no reason to believe now, of course, that doesn't apply in the case for web development as well. So the author really provides some nice examples on how to implement the patterns using diagrams for Android development as well, and it's certainly worthwhile having a look at this. Okay, so a huge amount of work has happened in the last couple of lectures, okay? Here's a list of articles that I've used. Now, you don't have to look at all of these or read any or all of those. They're saved here for reference purposes only. If any pique your interest, just go for it, And sometimes students think that I have to read everything that's referenced, and then it becomes a little bit overwhelming. These are just for me, the lecturer, because I have to read everything. Well, a lot, okay? But it's useful. So there's a good lot of stuff here. So really what's important here is that we review the three main architectural design patterns for web dev: MVC, MVP, and MVVM. Lots of differences in performance, maintenance, testability, depending on the pattern that you choose. There's no recommendation as to which is better for some unknown app, but you can probably make an estimate based on the research of others. If you choose to use a particular framework, then you're mostly stuck with the pattern provided. So if you use AngularJS, or you use React, or you use Vue, then you're stuck with it. Okay, so you don't want to worry too much about that. But you will be using a framework for large apps. But the main point really is that we need to think about design for our applications. A lot of work has already been done for you, so you end up using frameworks. These frameworks usually implement some architectural design pattern, and the structure of our app usually follows the recommended guidelines for development using that framework. In other words, there's a theory of web design, and even if we don't think about it, and that theory has been covered in the last couple of lectures. Thank you very much for watching.